Hello everyone. So this is a task of analyzing COVID-19 dataset. So first we'll talk about what's the main objective of this task. So we have to identify interesting pattern in this dataset, and parallelly we have to see relationship between the different variables which are contributing towards the dataset. Okay, so first we'll talk about our dataset. So what exactly this dataset contains? This dataset has a COVID-19 information like related to the COVID-19, how many total cases are there, how many new cases are there, what's the age factor, and this is from February to December. And as we all know that COVID-19 got started in India approx in the month of January or February. So we have a dataset till date up to the 18th of December. So now we are going to start our dataset exploration. Firstly, we'll start by importing libraries. Here we are importing libraries pandas, numpy, matplotlib and seaborn. And now we are going to read the dataset. As our dataset is in the format of a CSV file, so we are using pd.read CSV to read dataset. So first we are going to explore our dataset. How many columns are there in our data set and what exactly it contains. So if we'll see the columns of our data set, its continent, location, date, total cases, new cases, smooth, total death. So if we'll see all these columns, we can see that there are some columns. If we'll include those columns in our data set, are not going to see much information from that. So as per my understanding, I have dropped some columns, or we can say that I have selected some columns through the mechanism of feature selection. So I have created a new data frame with all the selected columns. This is the data one which I have created from the COVID dataset. Okay, so if we'll explore this new dataset, we can see that there are 54,932 rows in the 10 columns. Now we'll check for the data types in our dataset, like which column has which type of data. So from this we can see our data set is a combination of object data type and the float data set type. It means it has both the numerical feature as well as the categorical feature. Okay, so now we are going to move towards seeing the null values in our data set. So this is a percentage of all the null values present in a different columns. So we can see there is not such column which has a more number of null values which we need to drop. So we are not dropping anything as we have already selected the columns with the feature selection. So we'll keep all those columns as it is. So now we are going to see the correlation between different variables. What exactly it is? We are going to see like how one variable is related to another variable. So if we can see like all the diagonal elements are the one, it means they are relating in the full manner. As we can see, those are same, so it doesn't matter much. So we can see like this also, population and total cases, this is related to 0.6. This is a correlation coefficient. Okay, so the same thing we are going to see with the help of visualization, and we are using heat map for this. So this is a heat map which is representing the dataset which is given above in a visual manner. So from this we can see like if we'll see this block, we'll be able to see that this is a coefficient is almost 0.0. It means like age 65 older and the diabetes prevalence are not correlated at all. It means it doesn't matter whether a person is of a 65-year-old will have a diabetes or not. Okay, and the same thing we can see with the total cases also. So it's not sure like if the person having diabetes, he is going to have a COVID-19 as per this data set. So we have explored some information from this correlation map, and it's really useful for us for the further exploration. So now we are going to explore data through the visualization, which is the best way to look into the data. Okay, so now we are going to see relation between the continent and the number of total cases. So with this we can see Africa has a more number of cases as compared to other continents, and we will see the topmost three continents which is having the more number of COVID-19 cases, that are Africa, Asia and Europe. as we all know how these countries are suffering from this COVID-19. So as per our knowledge of this field also, we can see that our visualization is showing correctly. Okay, so now moving towards the next, we'll see for the locations also, which and all are the locations in the continent which are suffering most. So from this visualization, we can see Mexico is a location which is suffering most with the total number of cases, then Thailand, then Taiwan, like this. And now, if we'll see towards the date, what exactly this line plot telling us is like with the increasing time or with the increasing date, our cases are also increasing rapidly. And we all know this thing, so we all have evidence for this also. Okay, so now as we already seen, our dataset had both the numerical as well as the categorical features. So to implement any algorithm, we first need to convert the categorical features into the numerical one, or we can say we have to do the encoding. So for this, we are making the two different data frames. One will contain the numerical values, another one will contain only the categorical values. So here we have created two data frames, num and the character for care, and after this, now we are doing the imputation of our missing values. If the values would be missing in our data set, for the numerical one data set, it will be replacing by the mean, and for the categorical one, it will be replaced by the most frequent, means mode of that column. Okay, now we are going to see towards the data set which we have created now, num1. We are using describe function to see how many total cases are there, how many minimum cases are, minimum case would be one obviously, and how many maximum cases are there. Like this, we can explore our data set. So now as a part of cleaning our data set, we will remove some outliers also from our data set and from the numerical features. So here we are applying this outlier capping function or a numerical data set, and by applying this we can see that our outlier capping is done, as the minimum value and the 1% is the same, with the 99% and the maximum value is also the same. So it means we have done the outlier capping properly. So now time comes to the character encoding, as we have already discussed about why we need this one, because our algorithm won't accept character variables, so we need to encode them so that it could be converted into 0 and 1 values, and then we can apply algorithm to our data set. Okay, so this is the encoding that we have done on the character data set, and we have given the name char encode to the new data frame. Okay, so now we are going to concatenating both data frames, the numerical one and the categorical one. So XOR is the data set which is having all those values which are having in the numerator one, numerical one data set and the character encoding data set. Okay, so now we can see our data set, how it's looking now. Okay, so now we are going to do the feature scaling, as we'll have a large number of values in our data set, so it would be good if we'll do the standard scaling here. So now we are doing the scaling with the use of this standard scaler, and after doing the feature scaling, if we'll see this data set, how is it looking? So we can say all standard deviation values like in between the 0, 1, and now we are going to plot the elbow curve. So why are we using this? As we are going to use the k-means algorithm for this data set, so we have to calculate, or we should know what should be the optimum value for the clusters. So we are going to plot elbow curve for optimal cluster identification to find the appropriate number of clusters. So by this curve, what I have chosen the value of k as a 4, like I have chosen the 4 number of clusters for this. So from this we can see I have chosen the 4 number of clusters, and now I have fitted this one on our data set. And if I see, I can see the 4 clusters are created and how many values are there in each clusters.